Welcome to your Unit 3, Lesson 11, Part B notes. So we're going to continue talking about our secant, cosecant, and cotangent functions. So here's a challenge for you. Can you use your knowledge of the unit circle and the reciprocal relationships to follow through with this example number 5? So evaluate without a calculator by using the period of the function and values of the unit circle. So we need to find the secant of 13/3 of a pi. So the first thing I'm going to think about is where 13/3 would end up lying. If I subtract 2 full rotations, so 13/3 minus 2, which is the same as 6/3, would leave us at, 7/3 of a pi? So we would be at 7/3 of a pi, which 7/3 of a pi, again, needs to do another coterminal angle. So subtracting 6/3 of a pi again would get me to 1/3 of a pi. So this secant 13/3 of a pi is the same as secant of 1/3 of a pi. Okay, so secant is the same as the reciprocal of 1 over the cosine of 1/3 of a pi. And cosine at 1/3 of a pi, so 1/3 of a pi, cosine's higher, so we're not as far out, so at 1/2, and the reciprocal of 1/2 is going to be 2. Okay, so 17/4 of a pi, figuring out that, so 17/4 minus 2 leaves me at 1/4 of a pi. So this is going to be the same as finding the cosecant of, what did I just say, 1/4 of a pi. Cosecant is the same as the reciprocal of sine of 1/4 of a pi. Sine of 1/4 of a pi is root 2 over 2, which really is the same as 1 over the square root of 2. Oops, I wrote 2, which would just get us root 2. So the cosecant at 17/4 of a pi is root 2. Cotangent, again, let's first figure out our coterminal angle. So cotangent, so 9/2 minus 2 puts me at 1/2 of a pi, would be the coterminal angle. Cotangent's the same as 1 over the tangent of 1/2 a pi. So now let's think about the slope of my terminal ray of 1/2 a pi. It's going to be undefined. So 1 over 0 technically is what it would be, right? Because undefined is 1 over 0. So the reciprocal of 1 over 0 is 0 over 1, which would just be 0. Would be your answer here. And then negative 17/6, I'm going to add 2 until I end up inside my 0 to 2 pi range. Oh, goodness gracious. I'm not doing very good with my calculator work here. I'm being lazy. So that looks like we're at negative 5/6 of a pi. So the secant of negative 5/6 of a pi. All right, well, negative 5/6 is here. That gives me a reference angle of pi over 6. Secant is the same as 1 over the cosine. Remember, the cos don't go together. So the cosine, or my horizontal displacement there, is going to be longer. So it's going to be root 3 over 2, but it's going to be negative root 3 over 2. The reciprocal of that is negative 2 over root 3. Rationalizing that gets you negative 2 root 3 over 3. Okay, so now, if we look back at our ratios from example 1, can you name the reciprocal identities and quotient identities in terms of the trigonometric function? So our reciprocal identities are 1 over the sine of theta for cosecant. Secant is 1 over the cosine of theta. Cotangent is 1 over the tangent of theta. If we think about tangent in terms of y over x, and remember y is our sine, x is our cosine, tangent would be the same as sine theta over cosine theta. We call this our quotient identities. And cotangent would be the reciprocal of that, so cosine over sine. So now, when given the terminal point of an angle rotated on a coordinate plane, you should create a right triangle by dropping a perpendicular line back to the x-axis and then using the Pythagorean theorem to solve for the hypotenuse. So moving on to example 6, find the exact values of each of the 6 trigonometric functions of an angle if negative 2, 5 is a point on the terminal side. So let's kind of make our quadrant 1, quadrant 2. If we're going out to the left, negative 2, up 5, make our terminal side. Pythagorean theorem would be the square root of 5 squared, so 25, plus negative 2 squared, so 4, so root 29 would be the length of our radius. Here's our theta. So now, using that triangle, can we come up with all 6 trig ratios? So the sine of theta, I'm going to be lazy, I'm not going to rationalize, would be 5 over the square root of 29. Cosine of theta would be negative 2, so x, or adjacent, over the hypotenuse. Tangent of theta is opposite over adjacent, or y over x, so negative 5/2. And then let's do the reciprocal function. So the reciprocal of sine is the cosecant, which would just be root 29 over 5. Reciprocal of secant would be negative root 29 over 2. And then cotangent of theta would be equal to negative 2/5. Example 7. Given sine of theta is equal to 2 root 13 over 13, I'm going to automatically turn that into an unrationalized fraction. So that would really be 2 over the square root of 13. And I'm going to do the same thing for my cosine. So cosine of theta would really just be 3 over the square root of 13 if we unrationalize that. And that's just dividing by the root 13 on both sides. Okay, so now find the exact values for the 4 remaining trig ratios. Okay, so this would be my sine, would be y over r. This would be x over r. So x is equal to, what did I just say that was? 3. Y is equal to 2. My radius is equal to the square root of 13. Right, if you visually needed to see it, 3, 2 square roots of 13 theta. So now we have sine, cosine. Let's find tangent. So the tangent of theta is equal to y over x, so 2/3, or opposite over adjacent. The cotangent would be the reciprocal of that. And then the reciprocal of sine is the cosecant. So that would be root 13 over 2. The reciprocal of cosine is the secant, which would be root 13 over 3. So there would be all the 4 remaining trigonometric functions. All right, example 8. Given the graphs below, use the suggested functions to write equivalent equations. So we're going to write 2 different equations using the cosecant and the secant given the actual graph. So when we have a graph of a reciprocal function, remember it's going to be outside of the range that we would normally have for sine and cosine or tangent. So for this one, we make a skeleton graph. So put a dot at your vertices of those given parabolas. Put a dot at all of the asymptotes. And then we can kind of dot out our periodic function and then hopefully identify what it is. So hopefully you can see that it is not a sine graph. It's a cosine graph. It's a cosine graph reflected across or about the x-axis. So there's going to be a negative in front of it. So we have a negative cosine graph. Let's see, does my period change? So if I go from here back down to here, or actually I guess maybe I could do it better. Let's do top to top if I do it this way. We have a period of 2 pi, so my period is unchanged. So if we do it as a cosine with the negative, right? So if we had our originally y is equal to negative cosine x is the graph in yellow, then the graph that we actually want would be negative secant x would be our answer there. If we went off of that yellow graph. I could have, what's another way we could have done this? So we'd go back to our same dotted graph. I could think about this as a sine graph, right? So I could start my sine graph here and do a phase shift to the left half a pi, which would then be, so sine's reciprocal is cosecant, phase shift to the left, so plus half a pi. That would also work. Or, nope, that wouldn't work. I wouldn't want it to the left. I would want it to the right. That way I would need a negative in front of it, right? So there's another way we could have done it. If I went with a minus half a pi, then I don't need that negative, because then I would be starting here, up, down. So I start at the wrong spot. So again, multiple ways that we could have written that out. Hopefully you can get yourself to one. For B, did our period go unchanged? Does not look like it did. It still looks like we are at half a pi for a period. So we can see clearly that it's a cotangent because it is decreasing. So we could just flip it and make it a negative tangent. And then it would be, oh, I was supposed to do it for a secant. Did I do a secant and cos? I just finally read the directions. Right, two different equations using cosecant and secant. Okay, I did that in part A. Go us. Cotangent and tangent. I'm going to go with the tangent one first. So tangent normally we know is like this, right? So if I make it a negative, then that would make it decreasing. And then if I do a tangent, it looks like we're shifting over a quarter of a pi to the right. So minus a quarter of a pi. To turn it into the cotangent, so our cotangent is originally starting with our asymptote at 0, right? So it's normally here, but we're moving it to the left a quarter of a pi. So cotangent of x plus a quarter of a pi. So both of those equations would represent the graph that's graphed there. All right, let's finish this up. Last page. So, phase shift, standard form equations. If we had the equation y equals 2 times the cosecant of x minus half a pi, identify the values of a, b, c, and d. Our a is positive 2, my b is 1, my c is half a pi. Right, so that's our half a pi. We're not adding going up or down, so d is actually 0. Nothing's happening with my vertical movement. So we're going to just graph it like we would normally graph it. Oops, bring that back. I want to erase that. Okay, so what we want to do is we want to first start with our phase shift, right? So we're phase shifting, so start with our C. We're phase shifting to the right, half a pi, so positive half a pi. And then we're going to add a full period, right? So my period's going to stay 2 pi. So half a pi plus 2 pi gets us to what? Oh, hold on. I'm jumping the gun here. Find my period. Period. 2 pi. Now I got to find our stopping point. So I'm going to take beginning, half a pi, adding a full period of 2 pi, which gets us to 5/2 of a pi. And then we're going to create our 4 intervals, right? So we're going to start at half a pi. We're going to end at 5/2 a pi. Directly in between that is 3/2 pi. In between half a pi and 3/2 pi is pi. In between 3/2 pi and 5/2 pi is 2 pi. All right, so we have our start. And because we're doing a cosecant, that's the reciprocal of sine, which means we're going to start at an intercept. We're going to go up to a max because I'm not reflecting it across, back to an intercept, to a min, back to an intercept. Okay, then I'm going to dot that out as a graph. So we're going to start at half a pi as an intercept and at 5/2 a pi intercept. I'm going to hit a min at pi, but I'm going to go up 2 because that's my amplitude. And then at 2 pi, I'm going to go down 2 because that's my amplitude. And then I'm just going to keep on keeping this pattern. Dun, dun, dun. Oops, went too slow there. There we go. So I can get a pretty good skeleton for the reciprocal function. So the only reason I'm graphing out the skeleton of the sine is because that's going to tell me where my asymptotes are, and it's going to tell me where my vertices of the parabolas, if you want to call it that, would be. Okay, so now at my zeros, we're going to put asymptotes. And then at my max and mins, we're going to create little parabolas that look like this. And then there would be our graph. Okay. So graph the reciprocal function. The reciprocal function we graphed was 2 sine of x minus half a pi. That's what I did in the dotted lines. Okay, let's do one more. So we have y equals negative secant 2x minus pi minus 1. So again, we could factor out the b to get that phase shift right here. If I don't factor out the b, then I'm going to get my phase shift by doing the c over b, which would just be the factored out form anyways. So my vertical shift, so we factored out a b. My vertical shift is at -1. So we're going to scoop that midline down at -1. So let's dot that in so we don't forget it. My phase shift is my c over b, so half a pi, and we're moving to the right. My horizontal transformation, so my period, 2 pi over 2, means my period is now pi. And my reciprocal function for secant is cosine of 2x minus pi minus 1. Okay, so my starting point is at half a pi. I'm going to end at a full pi over, so 1.5, so 3/2. Halfway between those two numbers is a full pi. Halfway between 1/2 and 1 is 3/4 of a pi. Halfway between 1 and 1.5 is 5/4 of a pi. Okay, and because we're cosine, we're going to start at a max. Yep. Oh, nope, we're starting at a min because of that negative in front. Means we're ending at a min. We're going to hit our max in the middle, intercept, intercept. Okay, so let's dot out that skeleton. So at half a pi, we're going to have a minimum. My amplitude is 1, so I'm just going to go down 1. At a full pi, I'm going to go up 1. And then at 3/2, we're going to be here, and then quarter, quarter. And then just kind of follow the same pattern. Dun, 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 dun. Dot it out. Make our asymptotes at the zeros with the midline. And then make your parabola shapes. And then there would be the graph. And once you finish that, we are done for notes.